Good morning, everyone, and thank you for joining us today for this product webinar. We're going to get started. Your presenter for today is Steve Maves. He is our vision specialist here at Warner Electric. All of you have been placed on mute for the duration of the call. We're going to be unmuting all the lines at the end for any questions, or you may also type the questions into the chat Q&A box that you have on your screen, and we will address them all at the end if we don't get to them at that point. So we're going to go ahead and get started, and I'm going to let Steve take it over.
Thank you, Nicole. As Nicole said, my name is Steve Maves, and we don't have time or technology to take your questions during the presentation today, so I'm going to save at least 15 minutes at the end of the hour for your questions. So let's go ahead and get started. Our agenda this morning is basically Machine Vision 101. We're going to talk about what machine vision is, what it can do, and how it can be used on your assembly line. So we'll start right in with the basics of machine vision. Waiting for an update here. Okay, what is machine vision? It can be thought of in several different ways. So what is it? Is it taking an image of a part as it travels down the assembly line and doing a quality check on the part? Is it lighting the part up on the conveyor so that certain features of the part become visible to the camera? Or is it reducing a huge set of image data down to a small amount of useful information? The typical information that you get is just a simple pass-fail. Either it's a good part or a bad part. Or is it all of the above? And it is all of the above. There are many different ways to come at machine vision because there are many facets to a machine vision solution. There's the part on the machine or on the conveyor, how that part is presented. Does it stop in front of the camera? Is it in continuous motion? There is the lighting aspect. How you light the part determines what features or defects will be visible in that image to the camera. There's optical selection. So different optics allow you to see a larger area from a short distance or a smaller area from a long distance, depending on the lens that you choose. And then, of course, the camera, the lower resolution, lower function cameras are less expensive. Higher resolution cameras are more expensive. And the software that determines whether the part is good or bad. So those are all aspects that we will discuss today. But there are many different ways to think of a machine vision solution, and many aspects that we have to address before we specify a solution. We want to make sure that Warner provides a machine vision solution to you that will work. So here's a block diagram of a vision system. Starting on the left, you have some parts. You're either trying to find defects on the part, measure it, locate where it is on a conveyor, some machine vision task that you're trying to do. And then as we move towards the right, there's a lens and a light source. So the light source illuminates the scene, including the part that you're interested in the background. And we have to consider both of those objects when we pick a light source. So the light hits the part, bounces off, and then goes through a lens to an image sensor. So the image sensor in machine vision is an array, usually a square array or a rectangular array of photosensitive elements that convert light into electricity. And unlike a simple photoelectric sensor that has only one photosensitive area, image sensor has an array of, hundreds of thousands or millions of these photosensitive areas that are called picture elements. People have abbreviated that to pixel. So if you've heard that term thrown around, pixel actually means picture element. So we have our hundreds of thousands of light points in an array that form an image, and that data, that electricity is actually an analog signal on the image sensor, and then it has to be converted. So the next block on the diagram is an analog to digital converter that converts the light, the image sensor converts the light to an analog signal. The analog to digital converter turns it into a digital signal. Once the image is represented digitally, it can be transferred into the memory of a computer. And these computers, range in size from a full-blown rack-mount industrial PC to a very small embedded computer. And we'll talk more about how the different pieces of a vision system are grouped together. That's distinguishing characteristic that separates the systems from one another. But they all have all of these elements. There's a memory that holds the software for the image processing, and then there's some kind of I/O, either discrete I/O or serial or Ethernet I/O to interface with the machine control. So in this diagram, I'm showing three arrows. One is pointing towards the left, and that's the output from the machine control input to the vision system to trigger the camera. And then the two arrows pointing to the right are a output from the vision system input to the machine control that indicates when an inspection was complete. And then the second signal would be whether it was a pass or a fail. So this is kind of a bare minimum wiring diagram for discrete I/O for machine vision. But a lot of times we just use Ethernet, and when you do that, then the amount of data is virtually unlimited. Hundreds or thousands of data points could be transferred very easily. Okay, so let's talk about the different ways that these components are grouped together. So here's a block diagram of what I would call a traditional machine vision system, where the camera and the lens and are grouped together, and then there's an analog signal between the camera and a frame grabber and a PC. So when I started doing machine vision 15 years ago, this is how all machine vision systems looked as a block diagram. And as an actual product, it would look something like this. So on the left, you see a small camera head with the electronics in it. And then you have an analog signal going down a coax cable to a PC. That PC would have a frame grabber board, which is a special analog to digital converter for video installed in the PC. And then, very importantly, you would have some kind of image processing software running on that PC to reduce the large amount of image data to some actionable information. So in this case, we're showing the Cognex software installed on that PC. And then the PC also has a I/O board, either Ethernet, serial, or discrete I/O to communicate with machine control, PLCs, process control, HMI, that sort of thing. So this is kind of the historical, traditional way to solve machine vision applications. 15 years ago, this was the only option, and we used it all the time. These systems are still available. They're still considered the high end, the fastest amount of throughput. So applications like inspecting wide, fast-moving webs of material, this is still the only option. But it tends to be a lot more unusual now because of the advent of the smart camera. Oh, too far. There we go. So a smart camera is basically, again, all the same components, but they're grouped together differently. So some smart cameras contain everything, including the light and the lens, the image sensor, the digital, analog to digital converter, all the processing, I/O, and memory. Some smart cameras contain just the image sensor, A to D, processor, and memory. It depends on the model, basically, how much of the optical side is contained inside the smart camera. But as a minimum, they contain the image sensor, the A to D, the processor, and the memory. So, as you might imagine, these systems tend to be less expensive, and one of the other major benefits of the smart camera is that it's not running a full commercial operating system. It's just running an embedded OS, and so they're very rugged and reliable, both mechanically because there are no moving parts, and from an electronics and software perspective because they're a closed operating system, no viruses, no bugs. Well, I shouldn't say no bugs, but very few relative to an open operating system like Microsoft Windows or an Apple product. So here's another representation of that same system with the optics on the left, lighting up some part. The part is the most important optical component in a machine vision system. Now, I'm going to say that again because that's often overlooked. When I do interactive training, that's a trick question that I like to ask, is what's the most important optical component in your machine vision system? And the answer is your part, because we can engineer the light source, the optics, the camera resolution. These are all things that we can control, but we cannot control the optical variation in your product that we have to inspect. So that's where we need to focus all our efforts. What is the amount of variation of good product and the amount of variation of bad product, and where's that line? Because so often customers are used to inspection using the human eye, and the computer software that we use to program these is really not nearly as intelligent as a person. So we have to really break the problem down into some very simple terms. If we're looking for defects, we're going to ask for samples of all the different kinds of defects and what we call the worst of the good and the best of the bad. So, obviously it's much easier to check defects that are huge than it is to find the subtle ones. So when we're evaluating applications, we want to make sure that we look at the most subtle defect categories. These are all things that I would help you with, or one of the other vision specialists. There are several people on the team here at Warner that are trained to do machine vision. So let us know if you have an application. So that is the conclusion of what is a machine vision system. And I'm going to move along to the application. If there's any questions, let us know. And again, we're going to save time at the end. So what can machine vision do? I want to start from a very theoretical level. I am going to show you pictures of actual applications, which is, what everyone's always the most interested in. But I'm not going to be able to show you applications of your specific industry, right? There's just so much different industry in our area here. So let's start from a generic level and talk about that for a few minutes, and then we'll move on to discussing specifics. So inspection, assembly, appearance, and measurement are all inspection tasks. So on the assembly front, anytime that you're adding one component to another, and that, especially if that's being done by a human operator, it needs to be verified that it was done correctly. But even if the assembly is done automatically, there are times when it needs to be checked with vision afterwards. Appearance, again, this would be more of a quality thing, like we were talking about earlier. If you know what the best of your bad product looks like and what the worst of your good product looks like, we may be able to find a way to do an automatic inspection to verify the quality of the appearance of the product. This is so important in consumer products, as we'll see later in this show. There are, if a consumer comes up to a rack and there are two products on the shelf, one looks very nice and the other one looks shabby, they're going to buy the nice one every time. So a lot of consumer companies have a lot of money invested in verifying proper appearance of the packaging of their product. Okay, measurement is something we haven't talked about much yet, but machine vision is capable of finding edges in the image and measuring between those edges. So we can very accurately gauge the size of products in the image or the position. Measurement is a very common use for machine vision, and it can save a lot of money because if we are able to trend the measurements in a process right behind where the process is performed, then if we start to see a measurement trending towards getting out of tolerance, you can react to that before you start to manufacture bad product. And so this can be a big money-saving capability that machine vision brings to allow you to correct processes before defective product made. 15 years ago when I started doing machine vision, we always, well, almost always, were doing the inspection at the end of the line and checking all the critical quality parameters at the end of the line. Because it was so expensive, you could only afford to have one system on the end of the line. But now that the costs have come down, you can drive that inspection back up into the line right after the process that may be creating problems. And then you can monitor that, again, catching problems before they occur. So that's inspection. The next topic would be guidance. Robotics are becoming more and more common in flexible manufacturing. And according to different industry estimates that I've heard from the robotics industry, somewhere between 10 and 25% of the robot systems that are being shipped today actually ship with a machine vision system installed on them. So the machine vision system on a robot would be used to find the position of parts that are loose. So say you had a conveyor, a large conveyor with many small products on it that could be located at any position on that conveyor. You can mount a conveyor or a camera over that conveyor looking down and locate the position of the items on the conveyor and then send those locations to the robot, and then the robot can come over and pick them up from wherever they are, even if they've, basically random positions on that conveyor. So it gives eyes to the robot. Automation, when people think of robots, they think of canned robots, but there are many different kinds of automation systems that need to move. Gantry robots that are just simple XY movements. And then alignment is another way of using vision. One of the most simple applications of alignment that I can think of is guiding high-speed webs of material like paper on a paper manufacturing line. There's a very wide web of material moving through the machine at high speed, and those webs have to be steered. Web steering requires some feedback about where the edge of the web is on the machine, and you can use a vision sensor, a low-cost camera that's in the $1,500 range to do that. So alignment is something that can be solved very easily with machine vision. And again, because of the costs being driven down, with these new categories being created of smart cameras and even vision sensors, these are the ones that I was mentioning in the $1,500 to $2,500 price range. We can use machine vision to solve a simple application like web guiding, where we would not use that in the past. Okay, the third category, and the one we probably spend the least time on today, is identification. Code reading, so traditional linear barcodes like the one shown in the image there, or the new two-dimensional barcodes like data matrix or QR code, can all be read using Cognex vision systems or vision sensors. Actually, there's a new category of products from Cognex that's called the Data Man that is just image-based barcode reading, and that's all it does. But there are other identification tasks that require the vision systems, the Cognex Insight or higher, and those would include optical character recognition. So optical character recognition is for an automatic system that will read back a printed set of characters on a part, and it's not barcode, it's just a human readable set of text, and that's very useful for certain types of applications like the lot and date code or things like that. Sorting is a generic category for machine vision. If you don't know which part is coming down the assembly line, there's a mix of parts, and you have to determine which one of the mix am I looking at before the next operation. That's something that can be done either by the color, the shape, so that's sorting. And all right, so the next slide, this is getting towards the end of our sort of generic discussion. We are going to get to real applications here shortly, so bear with me a moment. Machine vision has been and can be used in all of these different industries. So that includes aerospace, automotive, food and beverage, consumer products, electronics, glass, medical devices, metals, paper, pharmaceuticals, plastics, semiconductor, solar, which is actually just a subset of semiconductor. And then in non-manufacturing situations as well, like transportation and logistics and document processing. Okay. So regardless of what industry you work in, again, from a 10,000-foot perspective, the purpose of machine vision is to optimize product quality, drive down manufacturing costs, maybe by saving scrap or catching manufacturing trends before you make bad products, enable advanced automation like robotics, control traceability. and that means that all the information about the manufacturing of that product is available through the entire manufacturing process and then also on into the life of the product. If the part has a barcode marked on it that's directly marked onto the surface of the part, then that will follow that product through its entire lifetime. So here's what probably most of you came to see, and that is, what can machine vision be used for on my production lines? So again, the processing software tools on that camera, they can locate images, patterns in the image, find edges for measurement, count objects, and you can think of this as, the purpose of this software is to reduce the huge data set of the image down to some actionable information, like a set of dimensions on the part, or a pass-fail criteria about the quality of a surface. The data sets are getting larger and larger. The highest resolution camera that we sell now is a 5 megapixel camera, so that's quite large. There's a lot of data there, 5 megabytes of image data, and maybe all you really care about is 10 or 15 different dimensions on that part. So it takes quite a large processing capability to do this task. Okay, inspection. So what can we do for inspection? The first application we'll look at is a customer that's bottling water, and there's quite a few things you can do with machine vision. Check the fill level, check the label position, and we'll show you a couple of other ones as well. So here we see a slide on the left is an image from the vision sensor. On the right, you can see the conveyor line curving towards us. I guess the product is moving towards the front. The camera that's shown there is actually a Cognex checker vision sensor. So this is a little vision system with lower capability, but everything is integrated. The optics, the lighting, the process, the I/O, the camera, obviously. It has an Ethernet port now on the 4th generation of the checker product, and it's capable of doing inspections like this. So here we see a bottle passing by with the fill level is too low, and the checker, by looking through the bottle at the side of the bottle, can see that that fill level is not where it should be and kick that product out. Here's another bad product moving by on the line, and this one has a cocked cap. So, there's two problems with that cap. The obvious one is human health. If a customer got that and it had been open, there could be bacteria in there. But a less obvious one that I've heard about from some folks that do bottling and canning is they call that a leaker. And if they're using paper packaging, a leaker can cause the packaging to collapse on the truck. So a single leaker could cause a customer like Walmart to reject an entire semi-truck load of product because one cap wasn't put on it correctly. The product is collapsed inside the truck. They can't get it off. So that's a serious problem. Well worth spending a few $1,000s on the line to check. Okay, here's another application, same industry, bottling industry, and you can see on the right that they've upgraded to the Cognex Insight Vision system, because this system's doing a little bit more of an advanced task. So good product is going by, and then we'll show you a defect there. And you can see that that one in the middle, that label has not been applied properly. So it's both too high on the bottle and it's also angled slightly. And so this is a task that maybe the checker wouldn't quite be up to because we're verifying a large amount of graphics. So the Insight camera can be used. And it shows two cameras on the front and back. So if there's a different label on the front and the back, you can verify both of them. Okay, so let's leave the bottling industry and move to, this will be an automotive application for a disc brake and a caliper. So the red housing up at the top is the caliper housing, and it holds the brake pads. And then the big round thing is the disc, obviously. So here we see on the assembly line on the right side, the disc and caliper assembly is laying down on its side. In the cameras, our Cognex Insight cameras, they're also laying on their side. So the camera, the image that the camera sees on the left shows the caliper housing at the top and the disc vertically extending down to the bottom of the image. And what we're checking here is kind of subtle, but it's basically in that small red box on the left side, the right side of the disc, it has descended down, so it's not in the correct position. So this is a measurement application where they're measuring to make sure that the disc is in the correct position in the housing, the caliper housing. Same idea here from a different view, and you can see on the image there in the red box, in the small red box, on the left side of the pad is extending down too far. It's not seated correctly up in the caliper housing. And vision can be used to check that, and I think there's two cameras there, one for the disc on, or the pad on the top side and one for the pad on the bottom side. Okay, this is a little different one. It's hard to see the defect, but these cameras are checking for the presence or absence of a rivet in the top of the caliper housing. So on this image on the right side of the caliper housing, there's a rivet missing. And, you know, traditionally we might have solved an application like this with a photo eye. And if there's only two items that you want to check, then, you know, it's possible that a photo eye would make more sense than a vision system. But once you get into the territory of having 4 or 5 photo eyes mounted around a machine and having to individually fixture each one of those, that becomes very difficult to maintain. And one of the advantages of machine vision is what they call, different people call software fixturing or dynamic location, or there are many different names for it. But the bottom line is what the camera can do is search through the image and locate the part first, and then follow that up with checking the presence or absence of various features on that assembly. So for example, if these caliper housings move from part to part, then you can't use a photo eye anymore because you don't know where the feature that you're supposed to be pointing at is. And that's still an application that can be solved quite simply with machine vision. Okay, so here is the solar cell. And there's several things that we can check for on the surface of this product that are kind of quality related. So here we have a part on the conveyor. Camera's looking down from the top. And there's a crack in the lower left-hand corner of this solar cell. And you know, I think that's more than just a cosmetic defect. That's going to affect the function of the solar cell, so that one needs to be kicked out. All right, here's another view of the solar cell after the electrical traces have been applied to it. And if you look there at the defective unit, one of the traces is broken, so that will affect the electrical function of this solar cell, so that one needs to be kicked out and either reworked or rejected. Again, solar cell production at a different stage of assembly, and either some coating was applied to it or some step in the chemical process. And the defect on this one is a discoloration in the lower right-hand corner. This slide is kind of exaggerating the discoloration. It's actually a little more subtle than that. But given the proper lighting, they're showing the light coming from the camera. I can almost guarantee they were not using the built-in ring light for this type of inspection. But there are many different lighting techniques that will allow us to see coating variations and things of that nature on a product, be it a solar cell or any other surface that you might want to check. Okay, here's went too fast. Here's a card like you might see inserted into any PC. It's an Ethernet card, I think. And if we look down at the back of the connector with the vision system, we can verify that all 8 of the leads are going into the connector on the back of the unit. So there's a unit here that's failing because the 7 leads on the right are intact, but the 8th one is broken. And so that would be a non-functional unit. Here's another application on this same line where the circuit board card is laying down in a nest. And the bad one is angled. It's not correctly seated. And this is an interesting application because the problem could cause the machine to jam later on. So this would be an instance where machine vision is actually being used to protect the machine. It's not a bad product, and when it crashes in the machine, it'll be rejected by someone who has to clean the machine up. So there's really no risk about creating a bad product, but there is the risk of damaging the machine. So this is a common use for machine vision. People in the plastics injection molding industry, if anybody on the call has injection molding presses in their factory, we've sold quite a few vision sensors, the lower cost vision system, to look down at the die so that when the injection mold opens and it's supposed to eject the parts, it just verifies that all the parts are ejected, because if you ever close a mold onto a hard part that wasn't ejected, it can damage the mold. And so spending $2,000 or $3,000 on a vision system, if you saved yourself from damaging the tool even one time, it would pay back the vision sensor almost immediately. So it's a very common use for vision, is protecting the production line from the kinds of failures that occur on a regular basis, or at least regular enough to cause damage. Okay, so measurement is another large category of machine vision applications. So let's talk about a few measurement applications, and then we'll wrap things up. So, as I already mentioned, generating accurate dimensional information about 100% of the products that you produce can help you to fix problems before bad products are manufactured. Industry's been doing offline quality checks for a long time, and we will continue to use those. As we see here in the upper right-hand corner, this is the mouth of either a 20-ounce pop bottle or maybe a 2-liter bottle, and it's in the preformed stage. So this is a part that was injection molded, and then it will be usually sent to a different facility where they blow mold it up to the full size and then fill it. So the company that manufactures the preforms is less concerned about the dimensions of the bottom part because that part hasn't been formed yet. But the threads are formed as they will be on the final product. So they can accurately gauge all of the critical parameters on that. And you can see they're even gauging, you know, the position of the threads on the right is higher than that on the left, and because it's in the right position from part to part, they can check that as well. Okay, the part on the bottom is a metal machine part. It's a car part, I think. I'm not actually sure what it is, but you can see from the graphics overlaid on the image that they're checking the hole diameter for the two holes on the bottom of the flange, and then the large hole in the center that has a diameter check on it. There's a center position. That large green T is indicating the center of that hole. And then they're actually measuring the radius on the left side and in the upper right-hand corner of the partial arc. So you don't need a full circle in the image in order to extract the radius of some of those rounded features of the part. Here's a gauging application, gauging the threads on a spark plug. And of course, that's very important because the threads on the spark plug are wrong. They can damage the engine block, which is a much more expensive component than the spark plug. So you can see from this that the accuracy is very, very high, 0.05 millimeters or better. Now, it's also looking at a very small area, and that's a trade-off that we have to work with machine vision between how large of an area are you going to scan and what kind of a resolution do you need to hold. Here's another gauging application, measuring a spring. So measuring the overall length, the outside diameter, and even the individual wire diameters as it's wrapped onto this, whatever that rod is in the middle that's holding it. A second camera isn't there. The image is it's only showing one image, but there's also a second camera that looks down the end of the spring at this chamfer. If you look at the left side of the spring and the right, you can see that they're ground off flat, and that's a secondary operation. So that's probably being checked over closer to where that operation is. As I already mentioned, that's kind of best practices, is put the inspection right after the area where the operation is done so that you can have minimal scrap between the machining or manufacturing operation and the reject. Okay. Identification, we mentioned early on barcode reading. So here's the guy taking the part off an assembly line and using a hand scanner to scan that part, scan the barcode. And we talked earlier about the applications for the the water bottle line. And in this case, on the left side, there's a Cognex Dataman 300, which is a barcode reading specific camera. It's capable of reading barcodes at a very high rate, and that's all it does. So if the barcode is damaged or it's the wrong barcode because somebody loaded the wrong set of labels on the labeling machine, then there'll be a fail signal for that, and the operator can check and see if it was a one-time thing, the product can be kicked off, or if it was a mistake in loading the labeling, that can be corrected as well. The same little computer board, the electronic circuit board we looked at earlier, has a label on it. On the left side of the label, there's a linear barcode, and on the right-hand side is a QR code. And the camera system can read both of those, either with a special purpose camera meant to do nothing but barcode, or in conjunction with some other task being performed by that camera. So here's a defective barcode that was damaged somehow, and you want to get that off the line because the customer's not going to be able to use that code. So that's all I have for today. We discussed the theory, what is vision. We discussed generically what it can do to try to get your ideas going, and then we discussed a few specific applications in the real world. So that's all I have. Thank you very much, and now we'll have Q&A time.
So thank you, Steve, for doing this for us and for our customers. We don't have any question and answers on the screen at all. Does anybody have any questions for Steve?
Steve, this is Mike at LaSore Cheese.
Oh, yeah. Hi, Mike.
Hey, I just have the same question I kind of had a couple weeks ago about the ActiveX insert for Cognex for the Wonderware. Did you guys make any progress on that?
Yeah, so I talked to Cognex tech support, and I apologize for not getting back to you, but according to Cognex tech support, Wonderware is a fully supported package, but they don't have any example programs for it. So, they say it should work, and it says right in the help file that it should work, but they can't provide us with any documentation or a sample program about how to make it work.
Yeah, and that's kind of where I was.
So, do you guys have, I don't even have a license, so I can't try it. You have Wonderware seats at your facility?
Yeah, remember I showed you the applications that we have and how we're interfacing now with the Cognex?
Yeah, okay.
On our cheese line and then also on our bag line, but we would like to use or see how that works to see if it would maybe streamline some of the more bulkier processes that we have and get rid of a lot of the scripting that we do.
Yeah, okay. Let's take this offline, Mike. I'm going to call you and see if we can't. If you've got a seat of that software and I can sit and play with it for half a day, maybe I can figure it out.
Okay. Well, do you have? Yeah. Let's talk about this offline because I can probably get you a Wonderware license, a temporary one.
Oh, okay. All right. That'd be great. Okay, we'll talk. We'll talk later today.
All right. Yeah. Just give me a buzz at the plant.
Will do.
Thanks, Steve.
Anyone else? Yeah. Thank you, Mike. Anyone else? Okay.
All right, well, if there are no more questions, just want to remind people of some upcoming events we have. We have the MinPack trade show that this Cognex line is going to be featured at. That's the end of this month, October 31st and November 1st at the Minneapolis Convention Center. Information can be found about that event on our website. And then Automation Fair is also coming up November 6th through the 8th in Philadelphia. And you can look on our website for that information as well, or give any one of your automation specialists or account managers a call. Thanks, everybody, for joining us.